Hello dear students. So in this video we will be discussing about our next method of analysis of trust, that is method of sections. We have already covered and discussed our method of joint in our earlier videos, and in this method of sections will be discussed. So this method is suitable when forces are required only in few members. Okay. Earlier in method of joints, the forces have to calculate in all the members. Then we prefer the method of joints. And in this method of section, when forces are required only in few members, then this method will be suitable. Okay. And in this method also, truss is cut into two portions. Okay. So like this is your truss and this is your x-axis cross section and this is a cut, and so the truss is cut into two portions and equilibrium of each portion is considered, and the left hand part equilibrium and right hand part equilibrium is considered. Okay, so for two portion of truss the following equations of equilibrium should be satisfied. We know three conditions of equilibrium, that is summation of fx is equal to 0, summation of fy is equal to 0, and summation of mz is equal to 0. Now, to determine the unknown member forces, an imaginary section is cut in such a way that unknown force can be determined using above equation. Okay. So, by making a cut in the whole truss, then we will have unknown force values by using this equation, that is summation of fx, summation of fy, or summation of mz is equal to 0. Okay. Now, the important thing is the imaginary section may be vertical, maybe horizontal or zigzag or any other shape. Okay, like this is your inclined, this is your horizontal, and this is your zigzag part also. Okay, so the imaginary section may be of any shape. Now consider a truss show below and forces in members HG, this is your HG, CD, this is your CD portion, and HD are required, and HD are required. Okay, so we need to calculate the members forces in HG, HD, and CD. Okay, now the cut the truss along section XX and consider equilibrium of either left free body or right free body. Okay, so we cut here by considering all these members in which the force are to be required. So HG, HD, and CD, and this is our left free body part and this is our right free body part. You can see here this is your left free body, so this is your HG portion and this is your A hinge. Okay, hinge support are having two reactions RA and HA. This is your H, this is your C, H and C, and here we had a cut here, and this is your force in HG, HG here, this is your HD portion, so inclined member is HD, FHD, and this is your CD portion, so FCD. Okay, now if we consider our free body diagram of the right portion, and this is your B roller support, one reaction here, this is a F joint, this is a F joint similar. Okay, so this is a G joint and having external load P, this is your D joint, and now here consider here, now this is a FCD, this is a CD member, so this is we need to calculate the member forces in CD, we need to calculate the forces in HD, so this is your HD and the forces in HG. Okay, so this is a free body diagram of this whole truss. Okay, now consider the unknown member forces FHG, FHD, and FHG, HD, and CD can be found by using found for the following conditions of equilibrium either for left free body or right free body, that is summation of fx, summation of fy, or mz is equal to 0. Okay, so by making a cut in the whole truss and by considering the equilibrium of either left free body part or either right free body. Okay, so we need to calculate our member forces in a few members. So we should the suitable method of analysis of truss is method of section. Okay, so let's take some numerical problem. The pin jointed cantilever truss is loaded as shown below. So this is your pin jointed cantilever truss. Okay, and this is having roller support here. This is your hinge support. Okay, and this is your A, B, C. C is having external load of 40 kilonewton here, and the distance between uh, E support and D joint is 3 meter and 3 meter here, and this is your distance 3 meter again. Okay, so the force in member ED is required. So we need to calculate the member force in ED. Okay, so for this portion, what we need to do, we need to cut our whole truss. Okay, in such manner that we are easy to find the forces in ED. So here I am considering this portion. Okay, so see this figure. So this figure is having x-axis section and imaginary cut is here, and you can see the ED portion is also cut here. And if we draw the free body diagram of this joint E, so this is a joint E, and you know the reactions HF, roller support is having a vertical reaction or your normal reaction to the support, and summation of Fx is equal to 0. So HF is equal to HA. Okay, so hinge support is having two reactions, so the one is RA reaction and another one is your HA reaction. Okay, so by considering the equilibrium, so of summation of Fx is equal to 0, Hf is equal to Ha. Okay, now summation of Fy is equal to 0 means Ra, this is your Ra portion, is equal to 40 kilonewton. Okay, so this is your summation of Fy is equal to 0. And if I am considering the summation of moment at A point, this is your A joint, at this is a hinge joint, hinge support. So at this point all the forces moment is 0. Okay, so summation of M is equal to 0 here. So 40 into 3 plus 3 is 6. So 40 into 6 minus HF into 3. HF into 3. This is a HF into the perpendicular distance is 3. So at this point, okay, A point. So HF is equal to 80 kilonewton. So from here HF is equal to 80. It means HA is equal to 80 kilonewton. Okay. Now consider this joint E. So this is our 80 kilonewton. Okay, force, and we need to find the member ED, and we need to find the member AF. So in the question, the only the force in member ED is required. So this is our AF member here. You can see this is a AE member, sorry, AE member, and we don't know the force in this member also. Okay, so this is a cut, and using method of section, summation of Fx is equal to 0 means, or FED plus 80 kilonewton is equal to 0. It means FED is equal to minus 80 kilonewton. Okay, so by considering our summation of Fx is equal to 0, we have calculated our value FED is equal to minus 80 kilonewton. So minus sign indicating this is a compressive in nature. Okay, so option C is correct here. So by this way you can apply the concepts of method of section for the truss to find the forces in few members. Okay, so this is another question. The force in the member CD is, so this is your hinge support E, this is a roller support E, and the distance is A. Distance is A here. External load P is acting at hinge at this pin support pin joint A, and this is our 2P load is acting at D support. So we need to find the member in CD, member force in CD. So this is our CD part. Okay, so for this we need to cut an imaginary section in such a way that if we draw the free body diagram, then the required member force in which the force is needed to be calculated is also considered. So this is our CD member, and we cut this part in such a way that CD is also considered here. Okay, so this is the way how I cut this whole truss, and using method of section, if I'm considering the free body diagram of this part, upper part, so this is your A joint here, this is a load here, this is a B member, okay, B joint, and this is your again your C, okay, C joint, and this is your FCD here, okay, FCD here, and this is your FAD here, FAD here. Okay, so and you see here the these are the as this is these member BC and BA members carry zero forces, as it is denoted as zero, because you know that at this B joint no support reaction and no external load is acting, and the members BA and member BC are non-collinear. So by convention, these forces BA and BC, the non-collinear forces, carry zero force. Okay, so that's why BA is equal to 0 and BC is equal to 0. So here this is our free body diagram of upper portion, and consider the equilibrium of free body. So if I am considering the equilibrium of free body, so what we see, if I am putting summation of fx is equal to 0, so fx is fcd minus p is equal to 0, so fcd is equal to capital P. So it is positive in nature, so it is tensile. Okay, so the correct answer will be your P tensile in the force member CD. Okay, so CD is equal to or tensile in nature. Okay, so by this way you can uh, apply the concept of method of section if you require the forces in few members. Okay, now move on to the next question. The figure below shows a pin jointed frame. Okay, this is a pin jointed frame, and this is your hinge support here, this is a roller support here, and this is a joint. Okay, and pin jointed C, this is a external load 10 kilonewton, and this is a 2 meter 2 meter 2 meter. Okay, now what are the forces in members BE, CD and ED? So BE, CD, CD and ED and ED. Okay, so we need to find the member forces in BE, CD and ED. Okay, now what we need to do, we need to cut uh, this whole truss in such a way that our member forces which are required, okay, is also considered. Okay, so I am cutting here, so this is my section XX, so here B is considered here. Okay, so cutting a section through BC, BE and AE, BC, BE and AE, okay, AE, such that your member force BE is also considered here. Okay, so this is a FBC, force in BC member, and this is a FBE. Okay, and uh, I have drawn here the free body diagram of this portion, left hand portion here. Okay, so summation of MA is equal to 0 if we are considering moment at A point. So this is our pin jointed. So at this point our moment is value is 0. So summation of A is equal to 0 means this is our 10 kilonewton and this is a 2 meter distance. So 10 into 2. Okay, so plus FBE, this is our FBE member force into 2. Okay, perpendicular distance is 2 is equal to 0 means FBE is equal to minus 10 kilonewton. Okay, so FBE value is minus 10 kilonewton in compression. Okay, now consider equilibrium of joint D. Okay, now if we consider the equilibrium portion of joint D here, so this is a whole truss and the equilibrium portion of joint D is here. Okay, now this is 5 kilonewton. Okay, 5 kilonewton is acting here. Okay, so this is your 10 kilonewton, so 5 kilonewton here, 5 kilonewton here, so 5 kilonewton here, and D is, and FCD value we need to find here, FCD. Okay, and this is our FED member. So if I'm considering the free body diagram of joint D here, and we know summation of fx is equal to 0 means FED value is 0, as FED value is 0 because we are not having any forces in x direction except our FED, so FED is equal to 0. And for summation of Fy is equal to 0, FCD plus 5 is equal to 0 means FCD is equal to minus 5 kilonewton. Okay, so you consider here FCD is equal to minus 5 kilonewton, and from this FB is equal to minus 10 kilonewton. Okay, so by this way, you calculated the member forces in BC. So BC and the BE and sorry, so it is BE, CD and ED. BE, CD and ED. Okay, so minus 10, minus 5 and 0 is the correct answer. So the option is B, 10, 5 and 0. Okay, so it is in compression in nature if we are having minus sign. Okay, so by this way you can apply the concepts of method of section to determine the forces in few members in the truss. Okay, so move on to the next question. So this is the question: find the member forces in the member marked A, B and C for the truss as shown. Okay, so this will be done in next video. Okay, so thank you so much.